Okay, this is our second trial, and still I'm titrating. Yeah, until I see a colorless solution. Remember, we did our first trial and it was 28.5. Now this is our second trial. We want to see an end point. Yeah. Yeah. Oh. This is now a colorless solution. I record my volume. Still it is 28.5. So my initial was 0.0, final 28.50. So volume of hydrochloric acid which has been used to neutralize the base, it is 28.50. So lastly, I do my third trial. You have to read carefully the conical flask. So once again I fill the third and last trial. I fill the burette using the hydrochloric acid, which is of 0.2 molar. I have bypassed. So I make sure I reduce. Yeah, I'm at 0. Sorry. I cover the reagent bottle. Then this is the pipette. Once again, I pipette 25.0. I pipette 25. I pipette 25.0 of the base, which is sodium hydroxide. Remember, sodium hydroxide is a strong base. Into the conical flask. There. Then I add 2-3 drops. So 1, 2, 3 drops of phenolphthalein indicator. Then I titrate. I open the tap again. I titrate until I see a color change. I titrate until I see a color change. So I'm rushing because I know exactly where the end point will be. But you are supposed to go slow by slow, because when you rush, you may bypass the end point. You may bypass the end point. Wow. Wow. I go slowly. Yeah. Stop. So this is a colorless solution. I record now this time it is 28.6. So my initial was 0.00. Final it is now 28.60. So volume of hydrochloric acid used is now 28.60. So now I'm done with my titration. Now this is ready for cleanup. Next is calculation. Since we have our volume, calculation in order to determine the concentration of our acid used. So remember, trial 1, we got 28. Trial 1, we got 28.50 plus trial 2 value, which is 28.50 plus trial 3, which is 28.60. We divide all this by 3, and all this is in cubic centimeter. I have my calculator with me. So 28.50 plus 28.50 plus 28.60. I divide by 3, I get 28.53 cubic centimeters. So this is cubic centimeters of hydrochloric acid used to neutralize the base. Okay, so remember, volume of pipette used to pipette the sodium hydroxide was 25.0. That is what we pipetted into the conical flask. So lastly, we're going to calculations. So step 1, which is our first step. Step 1. We have to convert the volumes, this volume of hydrochloric acid and the volume of sodium hydroxide in the pipette, into decimeters cubed, from cubic centimeters into decimeters cubed. So 25.0 cubic centimeters of sodium hydroxide. So in order to convert it into decimeters cubed, we get 25 divided by 1,000. So everything has to come with proof. 25 divided by 1,000, you get 0.025 decimeters cubed. So HCl was 28.553 cubic centimeters of HCl will equal to 28.53 divided by 1,000, which equals to 28.53 divided by 1,000 will equal to 0.02853 decimeters cubed. Step 2, we have to know the number of moles. Now we calculate step 2. Step 2. Number of moles of hydrochloric acid that reacted will equal to number of moles of hydrochloric acid that reacted will equal to molarity times the volume. So remember, the molarity of our acid was given, and it is 0.2 times the volume. Our volume of HCl is 0.02853. So 0.2 times 0.02853. So this one is giving me 5.3.706 times 10 to the negative 3 moles. So remember, we have the equation, which is sodium hydroxide aqueous plus hydrochloric aqueous equal to sodium chloride aqueous plus water, which is a liquid. So from here, this is a balanced equation. So 1 mole of sodium hydroxide reacts with 1 mole. So mole ratio is 1 to 1. Then that means if the number of moles that reacted for HCl was 5.706 times 10 per negative 3, then that means still 5.706 times 10 per negative 3 moles of sodium hydroxide reacted. So if we have the moles of sodium hydroxide and we have the volume, which is here, then we can calculate the concentration. So in order to calculate the concentration, we have to get the number of moles. So in order to get the concentration of sodium hydroxide, remember this sodium hydroxide is what we put in our conical flask, and that is why we are carrying out this experiment. So concentration will equal to moles of sodium hydroxide divided by volume of sodium hydroxide. So the number of moles of sodium hydroxide that reacted, we have them here, which is 5.706 times 10 per negative 3 divided by volume of sodium hydroxide. Remember, this volume is what we put in the pipette, what we pipetted. So it is 0.025 decimeters cubed. So I get my calculator. Remember, I still have my answer here. So I divide this by 0.025. So it is 0.22 moles per decimeter cubed. So, ladies and gentlemen, our final concentration. So the concentration of the sodium hydroxide, which was provided to us by the examiner or someone else, because I found it here, that's why I'm answering it, is 0.022 molar. That means our unknown concentration, sodium hydroxide, which was given us as solution A, is 0.22 molar. What does that mean? The mole ratio is 1:1. If then our acid was 0.2, still our unknown solution is 0.22 molar. So I thank you for attending me. Until next time, I have been Ntale Patrick, Lab Technician, Kampala International School, Uganda.
Thank the Lord.